Welcome to the Teacher Enrichment Program's Bite of Science. Our Bite of Science webinars brings together scientists and engineers from industry, academia, and government with secondary STEM teachers to expose teachers to new exciting science technologies and explore a variety of topics that illustrate the interdisciplinary nature of STEM and the real world applications of STEM skills. Following this session, this video, presentation slides, and supporting materials will be uploaded to our TEP lab bench for teachers to access and use in their classrooms. The Center for Excellence in Education was founded in 1983 by Joanne DeGeneiro, who is our current president, and Admiral Rickover, who is the father of the nuclear navy and civilian uses of nuclear power, with a mission to nurture high school and university scholars to careers of excellence and leadership in STEM. Our programs for teachers and students includes our Research Science Institute, our USA Bio Olympiad, our Teacher Enrichment Program, and our newest program, STEM Lyceum. All programs will be listed in the chat along with their links to learn more about them, again, along with this video that will be edited and shared on CEE's YouTube channel and social media platform. We are excited today to have three amazing speakers to join us this evening. We have Adi Karisik, with he's the global technology leader for operational technology and cybersecurity with Jacobs Engineering. And we have Kelly Retcher, who's corporate social responsibility with Tata Consultancy Services. And we have Evan Wong, who is a mechanical engineer with Lockheed Martin. And again, we are so excited to have our speakers here with us today to share with you guys some very interesting and amazing things that they're doing in STEM. So without further ado, we'll go ahead and start with Adi.
As you heard, my name is Adi Karisik, and I serve as a global technology lead for operational technology cybersecurity for Jacobs. What I would like to do is tell you a few things about what we do, how is that relevant, and what makes it cool or not cool to work in that particular field. So a little bit of my background, I've been in the industry for a little bit over 20 years. We provide cybersecurity services for over 500-600 critical infrastructure clients, national security clients, manufacturing clients. I mean, you name it, we have some sort of involvement with them. So a lot of times when we talk about this topic of technology and cybersecurity and what's the operational technology, I usually tell people it's everything what information technology is not. And basically what we're trying to protect, if you're working on an information technology side of business, you're protecting the confidentiality, the secrecy of sacred data, personnel information about your people, their salary information, their medical histories, where do they reside, their family status, stuff like that. On operational technology side of equation, we do not really look into that. We look at protecting physical things that make a difference in life. And I'll share a little bit about how that works. So in today's society, people talk about cybersecurity, and 99% of the time, the views of what cybersecurity really is are twisted or not exactly accurate as to what we refer to as cybersecurity. But in terms of cybersecurity, there are two main areas of cybersecurity: IT, which is the data or information security side of things, and OT, which is operational technology. If I use this simulated glacier as the example, this gives you the idea of the size and needs that we do in terms of the cybersecurity. OT cybersecurity is not visible. You don't see it on a day-to-day basis. You don't think about it, but it's huge and omnipresent. I'll give you an example. My spouse, my wife, recently bought us a new refrigerator. Well, this refrigerator connects to the internet. We're both cybersecurity professionals, but I don't really have a separated firewall or antivirus for an operating system used by Samsung refrigerator. Coffee makers, the Keurigs are connected, the doorbells, everything is getting automated and connected, and it exceeds the contemporary capabilities of a normal household to deal with this. So why do we do this? We came from engineering. Jacobs is known for engineering. But if you think about it, first of all, there are trillions of dollars of infrastructure assets worldwide that need to be protected. Everybody's adopting smart technology, and we build college campuses and universities and smart cities around the world, and nobody's asking you to build something that's not smart and not connected. I am yet to see the requirement asking us to build a dumb city. No, we build smart cities, and smart means connected, and more connected you are, the bigger the potential footprint of attack vector that you have. So what type of clients do we serve? It's like water systems, variety of industrial processes like robotics, automation, your healthcare stuff, transportation, security, defense, manufacturing, you name it, we're in that space. So the disciplines are very distinct, OT versus IT. Ultimately, they are the two branches of the same tree, but the problem with those is they grow in totally opposite directions. And somebody asked me recently, how do you recognize who is a IT versus OT cybersecurity engineer? Majority of the engineers in cybersecurity that are preparing to be an IT people have their dream job is to work in this office where they have 1, 2, or 15 huge screens and a super powerful computers to help them solve some really challenging work. OT cybersecurity engineers are worried about knee pads and steel toe boots and hard hats and helmets that we have to wear when we're in an industrial environment, when we have to climb or secure the things people don't want to think about, like crawl through a wastewater system and make sure that nobody gets control over dangerous chemicals that are used to treat the wastewater. Make sure that we're not allowing bad guys to change the composition of a drinking water in your household and so forth. So what kind of separates the two worlds of IT and OT is something that Purdue University came out in 90s, and it's known as an industrial model or a Purdue model. And if you think about it, this level 0, 1, 2, and 3 is where OT resides. And this is where your automation, industrial control systems, your HVAC is located, your alarm systems, securities, elevators, escalators, production processes. If you're in the military, weapon systems reside here and stuff like that. And then on the top, the level 4 and 5 is your application and cloud access, your email, internet, which is more associated to IT. If you look at how the organizations are being hit, it's external hacking, malware, and social engineering that lead the way. And why is this important? Because when we say hacking, it's not necessarily that computers are getting hacked. It's the humans that are getting hacked. And I'll play a portion of a very short video to kind of illustrate what I mean by humans getting hacked.
We're talking about cybersecurity today and how safe people's passwords are. What is one of your online passwords currently?
It is my dog's name and the year I graduated from.
And what's its name?
Jameson.
Jameson. And where'd you go to school?
I went to school back in Greensburg, Pennsylvania.
What school?
Hempfield Area Senior High School.
Oh, when did you graduate?
In 2009.
Oh, great.
And so forth. The objective of this is kind of just to give you an idea how vulnerable we are as humans, no matter what kind of password and cybersecurity hygiene we have. We love to share the information we sometimes shouldn't. This next thing is in terms of the operational technology cyber capabilities. This is the way I see the world. And how do we group different things into buckets of services? So I'm going to start with the very simple stuff, engineering and design. Let's say we're building a new smart campus building. So everything from how it's going to be designed, what wire is going to go where, to how do we protect information flow and how do we protect the industrial control systems, the access control, the security cameras and so forth goes into that bucket. The second one is managed services, which is typically after the building is complete and operational, and there is a problem that we can be on a call by, we can help, assist, provide remote access and stuff like that. Networking and cybersecurity is there from the beginning to the end. Industrial network are all bespoke. which means that they're proprietary and they're not two industrial networks that are designed to look the same. And the reason is the equipment's different, the processes are different, and they don't follow always the same template. Finally, governance, risk, and compliance. We're years behind our IT brethren when it comes to having formalized documents and standards. And it's easy sometimes to point people to the legislature or to a standard that they have to follow to be safer or to have a better cyber hygiene. But on OT side, there is really nothing that we can point them to. So we have to develop everything from scratch. Of course, variety of consulting services and advisory. And the last but not least, industrial digitalization is a different way of saying Industry 4.0 in domain of advanced manufacturing. And the reason for that, that we use digitalization instead of Industry 4.0 is I believe we're close to hitting Industry 5.0. And in our careers, we're going to see probably 6.0 as well. So we don't have to change the term all the time. We use one that's going to last a long time. So what makes Jacob special and why is it relevant to this is we're not just a company that helps other people. We also operate over 100 different utilities and key infrastructure elements around the world. And so we understand the pain, what it means to run an operation, whether it's a power utility, water utility, wastewater, the internet service provider or whatever, or if we are on a legislative side and need to figure out how to standardize their behaviors to minimize the risk. But why is this happening? First of all, as we said, nobody's building anything that's not smart anymore. This digital transformation and adding of new technologies has infinitely expanded the attack surface that we have. The bad guys are motivated. They are getting paid. And because of that, they're getting more aggressive and destructive. And majority of the security operation centers do not have visibility into devices that are listed as IoT, IIoT, or OT. So why is this important to the stakeholders? Because cyber attack on OT systems causes production downtime. Everybody remembers the Colonial Pipeline incident. That is exactly what happened. The other option on the IT side, you can lose the sensitive intellectual property. And finally, you can have some safety, environmental, or life hazard type of incidents. And I'll address a couple of those later. In 2020, the United States Critical Infrastructure Security Agency issued an advisory saying, all of you that think basically that these hackers will seize and they will attack us less, you're wrong. There's going to be more and more of that, and we need to prepare to live under that type of threat. Now, why do they have the ability to attack us? Because we're trying to make our life more convenient. The softest targets in the infrastructure are IoT devices. These devices are not necessarily always necessary, but they make our life easier. For example, instead of typing the PIN to get into the building, we swipe a card. And that card reader is an IoT device. And the only thing we know about it when we bought it is it was cheap and it comes from China. Nobody knows what kind of software it runs, how easy it is to hack into it or not, what kind of credentials are being used. But if it's cheap, it's built of cheap components. And because of how we connect these devices, the normal IT services have no idea if somebody's hacking into these external systems. So what we decided to do in our approach is to kind of build these series of technology labs that bring all kinds of technology partners together so we can jointly test, analyze, and look at the results of these to prioritize solutions that technology makers have to incorporate to make their technologies better. We do this in some countries in cooperation with high schools and universities, and we bring the students in so they can start getting understanding for this type of approach at the younger age. So another problem that we have with infrastructure, industrial control systems, and is that it's aged equipment. And the mentality of the people that design and use this equipment is they don't believe in a new invention such as cloud. Yes, we can install the systems that will assist you in the cloud, but 99.9% of the critical infrastructure clients want to have everything happen on their premise. They want to control the data. When you go into the global scope, our clients in Asia, are very strict about GDPR. Same applies to European clients. And you can't pull the data from country A into country B and store it in a data center there. So in a lot of cases, that on-prem solution becomes the only valid one. And how do we do this? It's this slide is sort of the 5 magic bullets of what OT and what we do is all about. We start with the premise we can't help you protect what we don't know you have. We need to know your assets. And the only way to do that is if we discover your assets and then figure out how vulnerable they are. So the step 1 is asset discovery. And because it's OT and it's archaic old equipment, we cannot start pinging devices and trying to analyze what they are, because I'll give you the example. Imagine if we were to ping the fire suppression systems in Lincoln Tunnel in New York City, and that bad ping can cause just one of those systems to activate and release thousands of gallons of foam. The damage to the city infrastructure in that particular field is immeasurable financially. So we have to do everything passively. Next thing is your risk and vulnerability management. Now, when we know what you have in your assets, let's figure out how vulnerable they are and what are your crown jewels? What are those assets that we cannot lose control of? Next thing is, once we've secured your assets, how do we monitor their behavior and how do we identify if there is a behavior that we would like to make sure it doesn't happen? That will increase your operational efficiency, and then we're going to design a system to unify your IT and OT risk management and security monitoring. The example of the events we do this type of things is I use a Super Bowl 2020 because that was a one where we were doing with Microsoft. And what we did was we designed a system that was taking over the water supply systems for the Super Bowl game. Because if you cut the power to Super Bowl, the game might stop. But if you really want to introduce some sort of a weapon to or some sort of harm to the populace in a stadium, you want to use water as your media. So, Super Bowl was there and passed, and there were no incidents. So that's typically a good sign that we did our job right. Now, who does this? And the threat comes from nation states that sponsor cyber terrorism, to insider threats, to a variety of threats. To make it funny, recently a client called me and said that they've been hacked and asked if we can send a team to help them solve their situation. So I took a look at the material they sent me, and they were asking me, should we call FBI? Who should be on the list? Who needs to know? And I told them this was a high school kid, in my opinion, who hacked your systems. And I said, well, how can you say that by being 1,000 miles away? I said, because they asked for a ransom of $100. If it was an organized terrorist syndicate, I promise you they're going to ask for more than $100. So the threat comes from many different angles. What do they want to hack? Everything: your power plants, electric grid, water treatment plants, natural gas pipelines, and so forth. So what can we do to make it more interesting? What we can make it interesting, first of all, is track where the attacks are coming from countries that sponsor terrorism, to our Department of Defense, who is trying to go through this exercise of how risky OT is. And they found out that compared to the IT, the OT risk on the Department of Defense surface is significantly higher. Another thing that is important, and I'm going to use this example a lot. This is an Australian example from a wastewater site called Maroochy Shire in Queensland, Australia. And what happened was a disgruntled ex-employee released 750,000 gallons of sewage water in a clean ecosystem. And the reason was he was a temporary worker for several years. They loved him. They opened the full-time position. He didn't get it. They walked him out, but they never took away his credentials where he could remotely log into the wastewater systems and direct the flow of wastewater. So he was so mad that he did a not very smart act, but very damaging to an ecosystem in which the plant is located. There was in 2017 a water utility whose computers were hacked on a manufacturing side, and that they were used as a server for a variety of operations and illegal transactions within the United States. So these things happen. And one more concept I'm going to share is how contemporary cybersecurity is. A lot of times when I talk about cybersecurity, people say, well, it's a new age thing. I'm too old to figure that out. I don't want, and one of the big concepts of cybersecurity is what we call defense in depth. And you go to any cybersecurity conference, they're going to talk about it. And it is so high tech and so contemporary and new that it comes straight from Middle Ages. It's same as the defending of a castle. So these layers of defense that you had in a castle, starting with the moat, then with the gate, then with the towers, with the archers, the courtyard that was controlled. We apply those same principles in cybersecurity, not to defeat the enemy, just to buy time, to give them something to work on until we can consolidate our defenses and figure out what's really going on. There are a variety of US standards that talk about that. And the typical ones that people talk about is NIST 853 and 882. A few slides ago, I gave you the idea of what the Purdue model is. And then I forgot to mention this yellow area that separates the IT and OT is called demilitarized zone, or DMZ. And this DMZ is another concept, brand new technology, very hard for humans to grasp because it comes from the Bible. It comes from the city of Babylon. And what it is according to the history, the city of Babylon had two sets of walls, the inner and outer walls. And due to the fact that there were diseases and hard to control situations, the merchants from within the city would come in this in-between area to do business with merchants from outside of city to limit the access of potentially people who can spread diseases into the city. This is the same concept we're applying. We're just calling it cybersecurity today. So in short, and I know I'm getting close on time, I'll give you a couple of very quick comments. In any environment, especially industrial control system environment, nobody's safe from potential cyber attack. Don't dismiss the threats and don't think you're safe because you have this software or this person who's really qualified. Everybody needs to be aware of what to do in case of cybersecurity situation. Don't be afraid or intimidated to ask for help. Know what you have in terms of resources. And, we are really good organizationally about talking about human safety and putting safety in everything we do. Security has the same connotations, and we should think about cybersecurity or digital security at large. As something that should be added to every task and every function that we do professionally. Lastly, I'll give you the example. About a few months ago, I was in UK speaking on a conference, and one of the questions they asked me was, well, if the fact is that the attackers are coming from internet, all we have to do is build those type of buildings that have no internet communication whatsoever, and we're going to be safe. Which is not necessarily true, but to give him a point, my answer was, you're correct to the point that you're trying to solve the problem of vandalized or burglaries in the houses by building houses that have no doors and no windows. It is, well, it in essence could potentially work. It's not the house you would want to live in because you'll never be able to leave. So it's not about cutting the ties, it's about controlling the access. And I'm going to stop right here. I believe I'm right on my time of 30 minutes and open it up for any questions, comments, or anything else that I could share with you that you would like to know.
Thank you so much, Adi. And so we'll have our question and answer at the end. So if you do have any questions, please use the Q&A function, and we'll be sure to read those questions out at the end. So again, thank you so much for that.
You're welcome.
Adi, cybersecurity is always just fascinating to me with the different aspects, and it just seems to be growing as it normally should as we get more smart devices and buildings and cars. So again, thank you. So now we'll move on to our next speaker, Kelly.
Thank you so much for allowing me to speak today. My name is Kelly Recker. I'm the program lead for Ignite My Future in School. I'm a former educator, and I am located in Pennsylvania. So before this, I was a middle school science teacher before coming to TCS, and I taught 18 years in the classroom. I'm sharing my contact info, so feel free at all times and anytime to reach out. Would love to connect. And so before I even get started about our program, Ignite My Future in School, I'd like to explain a little bit about Tata Consultancy Services, which is who brings us Ignite My Future. TCS is a global leader in IT services. We offer our customers digital and business solutions. We are the second largest IT company in the world with over 500,000 employees in 46 different countries. But you probably haven't heard of us because we're more behind the scenes. So we're business to business. We don't have a tablet or a phone or a printer, but we offer digital solutions for our customers. So you've probably used some of our apps or have gone to a store that we've created a point of sale system for. We're involved in pretty much any industry you can think of: healthcare, retail, a lot of different industries we're involved in. So I'm really excited to be here to share with one of our CSR programs, Ignite My Future in School. And one exciting thing I have to share, because it's coming up very soon, we sponsor the TCS New York City Marathon. We're the title sponsor of that. And so I'm going to start off just giving you an overview of our program. The Ignite My Future program is a pioneering effort through TCS to empower educators around the world to incorporate computational thinking into core subjects like math, science, literacy, social studies, and the arts. So our goal is to be able to help teachers to be able to bring computational thinking into any subject area that we teach. We know that teachers are on the front lines. They are the ones that are preparing our students for the future. And we know that computational thinking is a skill that you need no matter what type of business or job or role that you'll have in the future. So we want to make sure that our teachers feel prepared to do that. We know they're being asked to do so many things, so many extra things. And if they feel more confident and they have the resources, we know that they'll be able to share that with their students. We launched our program in 2017 with the goal of reaching 1 million students and 20,000 educators within 5 years. And we are proud to say that we did that in under 5 years. So far, we've reached over 30,400 educators and 1.78 million students. So that's something that is a big source of pride and excitement as we're trying to help change the landscape of education. So what is computational thinking? Well, the great thing is that computational thinking is something that we use every day. No matter who you are, you're using computational thinking. It's something that we know is going to prepare students for a challenge that they're going to face, because many of the challenges we don't even know what they're going to be. So obviously, maybe, for example, a pandemic comes up and we need to figure out how we're going to distribute vaccines. I feel like that happens sort of recently. So, it's stuff like this that we want to make sure that we're not teaching our students what to think, but we're helping them learn how to problem solve and take those problem solving skills and apply it to anywhere in their life. We identify 7 computational thinking strategies to do this. So collecting data, analyzing data, which we know is so important, finding patterns, so recognizing patterns in different problems and being able to notice patterns in different issues and then maybe apply the same solution there, decomposing problems, taking those large problems and breaking them down into smaller pieces so that they're more manageable. I know I always say I do this all the time with my family, dividing up the work in the house, to say, here are the chores, everybody take a room, and it makes that chore so much easier. Abstraction, so ignoring anything that's unnecessary, removing those unnecessary details and focusing on what is most important so you can solve a problem. Building models, so again, not just a 3D model or a hands-on model, but it could be a mathematical model, a computer model to help us solve problems. And then developing algorithms, something that we know we do all the time, the step-by-step processes to help us complete a task. So we define computational thinking as a higher order approach to problem solving that's going to use creative strategies much like a computer would do. And this is so important to us at TCS because this is something that we do all the time. And we want our students to be able to take all of these skills and teachers as well and put them into action no matter what role they have in the future. And so when we created this program, we wanted to make sure we provided professional development for our teachers. So that's one thing that we include. Everything is free. It's through our corporate social responsibility. I know teachers always love that. As a former teacher, if you said free, that was my favorite thing. So it's free, it's high quality, and it will always be free because it's through our corporate social responsibility piece at TCS. We have free professional development for teachers. We also offer lesson plans. So we have over 40 resources for teachers to use. And the lesson plans all include computational thinking strategies, like I had mentioned before, those 21st century skills that we know are so important, looking at collaboration, communication, creativity, getting all those 21st century skills so that students are practicing those as they go through the lessons. We offer, each of those lessons has guiding questions to ignite the curiosity for the students. And all the materials you would need for the lesson are included, whether it's links to websites that are included or handouts for the students. It is all involved. It all is included in there. And then they're all aligned to the standards. And then like Common Core and the SDGs and NGSS. And then we also make sure that they're connected to careers, because we always say you can't be it if you can't see it. So we want to make sure that embedded in each of these lessons, the students will go through their activities, they'll learn about the topic, practice their computational thinking, work collaboratively on that, and a real world scenario based problem. And then at the end, they can see, hey, if I really like this activity, I can look at this career. And this might be something that I'd be interested in. I shared these two examples. So we have transportation tech, which is a great lesson. Students get to act as transportation engineers. They work for they're working for a large school district, and they're tasked with fixing transportation problems that the district is facing by creating a new design for school buses, which I think many students would have a lot of opinions on school bus design. And then the other one is cyber defender. So not as much cybersecurity like Adi had talked about, but this is more like the social security, well, not social security, but security with students and cyberbullying. So students will assume the role of a software engineer that's tasked with using deep learning and developing a deep learning algorithm that's going to be able to identify forms of online bullying. So like I said, our lessons they have any question you could ask about it, it's answered in there. They're very robust. We not only have our PDFs, but we also have grab and go lessons, which we created when everybody had to convert to virtual learning. And so they're all the PDFs were transformed into PowerPoint that teachers can just basically grab and go and use with their students. And so I wanted to also share some opportunities that we have for teachers and for schools through Ignite My Future in School. One of those is the Ignite My Future Computational Thinking Family Night. So I know from being a parent, and so, even on the teacher side, you always have students will come home and say to their parents, we didn't learn anything today, we didn't do anything in school. And we know that that's not true. So our family nights are a great way to bring families together, engage our students in computational thinking activities. And then we also leverage our TCS or our partners, volunteers, to help guide the families through that themed activity. So these are about 45-minute sessions for families. We can work, K-12 students. We have our volunteers help run these activities so that the teachers, they can connect with us, the schools can connect with us. We ask them to provide a link and a date and a time that works, and then we work with them on a theme. But we can take care of the volunteer piece of it to help out the school as well. And our volunteers love being able to help our students and work with our teachers as well. And right now we're holding them virtually, but we can modify them for an in-person format. So that's one thing that we have that is available. We also have our Ignite My Future Computational Thinking Career Panel. So these are a great way to connect students with industry experts who are going to share their passion for their work while linking to students' hobbies and interests. So we want them to be able to see that, if this person is really into, students into data, and they think that this job is so cool because it involves data and math, that's something that they could see themselves doing. We teachers will connect with us, say this is what we would like to do. We'd like it to be on this topic. We've done topics from, whether it's a STEM based or sometimes a non-STEM based. So we've done creativity in STEM. So looking at, marketing and graphic design. We also have done like putting the M in STEM for, how our volunteers use math in their careers. We usually get about 3 to 5 volunteers. They're either from TCS, which I think I mentioned. We have a few employees, almost 500,000 we can tap on the shoulder to ask to join us. And we also have some of our customers that love coming in and sharing their careers with students. And then we work with the teachers and the schools to be able to make sure that this fits what they're teaching, what they want their students to learn. We also have our Global Innovations Project, which we're launching very soon. So I put the QR code and the link on there if you're interested. We are launching this in October. So actually right now, October 10th is when it kicks off. If anybody wants to join, it's still not too late. And this is one of my absolute favorites. Students get to engage in computational thinking with their teachers, and TCS is there to help guide them through it. So we offer teachers a lesson plan framework based on a real world problem. This time we're looking at inclusion with technology. So making our schools more inclusive to all students by leveraging technology. And they use their computational thinking to make this happen. So this was started by teachers. So teachers said, hey, we would love to be able to get our students to connect. One was in Mexico, one was in the US, and they asked us if we would help facilitate. And this was exactly, what we do at TCS every day, communicating and collaborating across different geographies. So we had helped create this, and the teachers helped create it. And so we facilitate it and the teachers implement it, and they can make it fit whatever works in their classroom. So we looked at COVID in my community as our first project, because when it first launched, we weren't planning on a pandemic, but it happened. So that lent us a great topic. Students have looked at food security and food desert, sustainability and sports, as well as green infrastructure. And like I said, this fall, we're doing inclusion with technology. So really excited about that. And last but not least, one thing that I think is really important for teachers is to have a community of like-minded people that can support them along the journey. And so this was life-changing for me as a teacher, being able to connect with other educators, because sometimes teachers are the only one in their building doing some of these things. And it was a great way for teachers to connect with people outside of their building, outside of their classroom, outside of their country sometimes. We have teachers from all over the world, and they create these global connections. They work on projects together, and they support each other as they're working through computational thinking. Anyone is welcome to join. You don't have to be an expert in computational thinking. You don't have to have taught for 20 years. You could be a new teacher, or you could be someone like myself. When I joined, I was a veteran teacher. So, and the whole, anywhere in between. So we would love for teachers, if you'd like to join that. That would also be wonderful. You can reach out to us. And so I'm gonna stop here. If anybody is interested, you can sign up for our newsletter. It's QR code and a link right there, so you can get updates on what's happening in the world of computational thinking, computer science, and any other opportunities that we have available. And then I also have a link here to our website that has our lessons on that. So if you'd like to check out some of our lesson plans, they are right there on that website. And thank you very much.
Awesome. Yes, thank you so much for sharing that, Kelly. I always get so fascinated by how much you guys offer and what you offer in terms of the lesson plans and the I don't know if I've seen that before. Do you have the 2 examples of what students can kind of do for examples in that? I absolutely love that.
Oh, great.
Absolutely love
Thank
it.
you, Travis. Thank you.
Mm-hmm. And last but not least, we will hear from Evan Wong with Lockheed Martin.
First off, my name is Evan Wong. I'm a optomechanical engineer working with Lockheed Martin. I started my STEM career going to Colorado School of Mines, where I got my undergraduate degree in mechanical engineering. During that time, was able to work in the lab. So that's kind of the image on the bottom right. After graduating, I started working at Lockheed and took night classes. I just finished my systems engineering master's degree. So that gave me a slightly wider technical breadth to the STEM field. Going a little bit more into my STEM background, started at Colorado School of Mines. I actually wrote for the school newspaper there, which provided some good communication skills that a lot of prospective engineers don't really necessarily think about, having to communicate with different team members in writing. My next STEM experience was in the field of renewable energy. For 2 years, I was working with a startup in Boulder, Colorado that was building wind turbines using concrete. And the reason why they were pursuing that is you can pour the concrete on site instead of having to transport the large steel tubes that you may see on railways and on the roads. And using that, you can get taller structures and capture more wind because there's more wind higher up off the ground. After 2 years working with that startup company, I moved and started doing research on campus with fuel cell technology. So fuel cell technology is essentially just a different way to consume fuel to produce electricity. Our specific application was to run a fuel cell in reverse to consume electricity to produce fuel. And the concept there was for energy storage applications, where you could use wind energy that was going to be thrown away because there wasn't demand at that time, say at night, and you could produce fuel that could be consumed later in the day. So it was interesting to go from real world startup experience to research, just because of the market need and just seeing how the different industries worked. All right, so after working in the fuel cell lab, I started my career with Lockheed Martin. That was supporting the U-2, and which is the plane on that left side, and the ground stations that process information that come down from them. So that was building server racks and getting used to a larger corporate environment. Also at that time, I started in the engineering leadership development program, which is a 3-year program within Lockheed where you get to rotate and try different disciplines, different programs, different products to really widen your technical breadth. During that time, I also started my master's with Cornell, which is where I got the systems. And I ultimately moved over to the directed energy team within Lockheed Martin, where we build the high energy lasers. And that is where I still am today, 3 years later. So current work is with the high energy lasers. We design and build lasers for DoD applications, different platforms. Something that I find particularly interesting is lasers have a lot of different requirements, and as such, I get to practice engineering with a lot of different flavors. So for example, the high energy lasers require a lot of power. So there's a lot of electrical engineers that I have to interface with, and also being high power, there's a lot of thermal problems that need to be addressed. So being able to think about cooling and how it's being managed and controlled with the system controller. There's also the optical engineering. How are we going to hold the optics and point the laser in a set manner and that's controllable and meets the system requirements? And then there's the general mechanical engineering of interfacing the laser to the different platforms. So it's interesting because I get to practice a lot of different parts of mechanical engineering to produce like one product. So kind of explaining what optomechanical engineering is in a little bit more depth, which is my title. It's kind of the process of building mechanical designs to hold optics in place and to control optics. Maybe one of the easiest examples is a camera, for example. Precision, holding all of these different lenses at the correct position, as well as the correct distance away from each other, that you get a usable image at the end. So packaging it in something that you could drop down a cliff and it would survive and still work. Another good example is the James Webb Telescope, which is on the bottom right, which is somewhat applicable to or similar to what I do, is how do you precision hold all of these mirrors to register to the same detector to get the images that we have been seeing for the last few months now that help us better understand our solar system and universe. Kind of going into what I do every day and what it means to be an engineer to me. First one is communication. It's every product that is built isn't built by a single person. It's not built by a single team. It's multiple teams that need to talk to each other and clearly communicate problems and work through problems together. And I think that's something that's often missed in STEM, is the collaboration that's required. Other skills from the more technical side, there's heat transfer for the thermal problem, solid mechanics for the optomechanical design and the larger structures. And then one that is kind of goes in line with computational thinking is a basic understanding of mathematical relationships. Almost daily, I sit in a meeting where we're trying to design and figure out how we can do something for the first time. And if we are able to implement this new material, what does it mean for the rest of the system? What are the benefits? And something that I pulled from my education is almost a database of different equations and how math actually works. So when it gives me the ability to frame a problem and understand if I pull this lever X amount, how is it going to change the strength of the material or the thermal capacitance of the material or the weight of the overall system. And being able to understand linear, quadratic, cubic, derivatives and integrals, just have a intuition for how those apply to real world problems in real life. It's can't be understated. Other things I do every day is their engineering and STEM is tied to software programs. So being able to quickly pick up a new program and understand it and be proficient in it is always a big plus. And then the last one that I find is a skill is organization. There's a lot of super organized engineers out there that if you ask them a question of something that they worked on 10 years ago, they will find it in 2 minutes. And then there's other people, if you ask them something that they did last week, they didn't write it down. So a saying that I've heard is, if it's not documented, it's not done. And it's one of those softer skills, but it's very critical to the STEM profession, in my opinion. So this kind of goes into my vision of teaching and how teaching can kind of be tailored to help teach this computational process and thinking that Kelly was just talking about. I frame it in teaching the engineering design process that we use during our STEM outreach events, which the first step is to brainstorm and understand the problem. So that would be the collecting the data, abstract thinking of what kind of concepts can we apply to this. The next is building a prototype, which would be building models in Kelly's framework, testing to collect data and see if our assumptions and how we understood the problem is correct, and then reflecting on the results and just repeating that process. Another one is framing math in school with real world applications. I remember in middle school and high school, it was learning equations on the whiteboard with a chart and not necessarily having it mapped back to real life. So mapping it back to, say, a structural mechanics problem or just general construction, I think it helps create that mathematical intuition that is useful in day-to-day engineering. And then the last one I have here is kind of specific to my experience with school districts, where different schools have specific STEM programs that some may be more medical oriented, some may be more tech or engineering oriented, but really making it clear to the students and the parents that the resources that are out there and making it accessible for the students to pursue the different passions across potentially different schools. And then this is just kind of a quick slide of resources that I have from my STEM outreach. The first one is the STEM activity that we've been doing through COVID, which is essentially a ray trace activity, which helps myself and students understand how optics work, how the shape of an optic affects light to travel through and how into different indexes of refraction can change things. Another is just my contact information. We've been doing virtual STEM events, which is the virtual activity and a presentation for the last few years. So if there's interest, please reach out. The last few links are, the first one is a quiz that Lockheed Martin put together, I believe, with National Geographic, where it's a few questions that essentially point you towards a potential STEM career that you might like, given your personality. So I found that kind of interesting. And then the last link is Engineers in the Classroom. So that's a resource for teachers. It essentially is a database of different STEM activities that you could do with your class. It lists out the material, recommended age groups, things like that. Has instructions that you can print out and just give to the different student groups. So it's a good website. And I believe that is all I have.
Our first question, let's see, would be for Adi. So what are some of the challenges that you see in cybersecurity? Like, I guess, futuristically going forward?
So I think the biggest challenge that we have is we don't have an adequate preparation of workforce. I was on a conference in Singapore, I don't know, maybe 8 months ago, 9 months ago, and I met with some execs from IBM, and they gave me some crazy statistics I never heard about. So everybody knows that there are a lot of schools and programs teaching cyber hygiene, cybersecurity, but it's all aimed at this base IT stuff, the information security side. They said that currently in the United States, IBM calculated about 160,000 job openings for OT cybersecurity people. Total globally available people that have OT cyber certs is roughly 250. So we don't have the schools and the universities or training programs that will get this connection and show the people that might have an interest. And I know it's not an easy career choice, but at the same time, at this moment, it's going through a renaissance, which means the income potential is pretty much unlimited because there is such a high demand and such a low supply of talent. So that, and that's where you guys as educators come in, and where you can at least showcase what is that profession does. And if you spark an interest in 1, 2, or 5 students, while it doesn't seem like much, that's 0.5% of the overall OT cybersecurity populace of the world. That's a lot. So that is I think the biggest challenge.
Okay, yeah, I feel you on that. We're going to have to do a better job, I guess, at exposing students to these type of industries and potentials, and to even get the school districts and the standards to kind of help with that too, because a lot of times there aren't any standards to really help with that. So
absolutely,
totally understand. Kelly, and so I wanted to know a little bit more on, can teachers reach out to you independently, or Do they need to go through their principal? And I know you mentioned the family night, which is a kind of a school-wide initiative. So you do school-wide initiatives as well as kind of personal. So if you could just speak to that a little bit.
Sure. Yeah. I mean, I would say yes to both. So, we have some teachers that, obviously, if they have to get it approved by their admin, we want them to do that, but they don't have to have their whole school involved. We would love it if they would get their whole school involved. I came to Ignite My Future because I heard about it, and then I got a whole bunch of the teachers involved because I loved it so much. So we can do it on an individual basis, or if a teacher wants to try some things out, do a career panel, and then would like to add a family night for their whole building, like that would be great too. So they can reach out as an individual, or if they would like us to also talk with their admin, we can do that as well.
Okay, awesome. And I do encourage teachers to definitely look that up. That'll definitely help. And our last question, so for Evan, so I like how you spoke on, students are going to need those hard skills, but they're also going to need those soft skills, which sometimes we don't really think a lot of in STEM. But I did want to ask you a little bit more on the inter-school collaboration that you had mentioned. Like, what does that look like? Or do you remember that part?
Yeah, I remember that part. So my past experience is my school district that I was working with in Colorado now a few years ago. Each high school has almost a specialized like STEM curriculum and STEM programs, where one is more robotics based, one is almost like a pre-med type experience. And then the last one is a lot of essentially coding experience. And it's one of those where the students don't necessarily need to transfer schools because it's outside of standard school hours, but making sure that that's communicated across the different schools and the different students to make sure that those opportunities are known.
So a student at school A could go to school B for their STEM program. Is that what you're saying?
Or even in high school, just like drive there for like classes, talking and seeing like what courses are working in like different areas. Because I think Kelly and Ignite My Future is an amazing resource of connecting different teachers. Like, even if you're the one teacher in the school doing it, you're not alone. So it's kind of a synergy with that.
Okay, and again, so what inspired you the most to get into engineering?
That is a great question. The cop-out answer is I didn't like writing in school, so I thought it was a great way to get away from it. You don't get away with it.
Of course.
In something that I found is that engineering in its way is its own art, where you're really creating something beautiful that's never been done before, and holding it in your hands a year after you came up with the idea and did all the analysis and spent so many hours to create this new thing that's never been done before. It's particularly rewarding.
Okay.
Yeah, so it's like that creativity, art, seeing results. It's what I enjoy about it now. Yeah.
Okay, so I want to say again to each of you, thank you so much for sharing with us this evening. I know for me it was really helpful, and I'm definitely sure for our teachers who are going to be watching and share with students, they will find this an amazing resource as well. So again, thank you guys.